Hi, good afternoon, everyone. My name is Mr. Bang, and today we're going to be solving equations using our algebra tiles, our manipulatives. So what I need you to do is go ahead and go into Google Classroom and click on the link for polypad.amplify.com that I have linked there for you for easy access. So I'll go ahead and give you some time to click on that. Click on a new polypad. Okay, so once you're on the screen, you should see the different concepts that we can use our manipulators on, our different geometry, numbers, fractions, algebra, probability, are different topics. Okay, and so what I'm going to be focusing on today is our algebra. So go ahead and click on algebra, and you're going to get this many different options for you to click. Okay, today we're only going to be focusing on two. I'm going to use our balance scale and our algebra tiles. So what I need you to do is click on the balance scale. Okay, first, I like to use both the tiles and the scale. So what I need you to do is click on this scale here, this gray one. So you should get this. If you accidentally click on something else, just click on the trash can and it should go away and you're fine. What I do want to talk about is the meaning of this. Okay, so when we're talking about balance, it means that we're equal, right? We're balanced on both sides. We are distributing the same amount of weight on either side of our scales. And so that is exactly what we need to keep in mind when we're solving our equations. It's not that the equal sign is talking about automatically solving something, because if it's already equal, what am I going to be solving for? Right? And so we'll talk about why we solve in just a minute. Okay, so the equation that I want to solve today, click on this text box here down at the menu at the bottom, and it's going to be, I'm going to keep it simple. We're going to take a journey back to sixth grade just so that we can see how this manipulators work. So we're going to solve x plus 3 is equal to 5. Okay. So the reason why I'm solving, I'm going to bring it back just now. Where the reason why we're solving is not because of the equal sign. It is because I have an unknown variable. The unknown variable means I have a missing piece. I don't know what the value of the x is. Okay. In this case, the variable is the x. And so I need to add 3 to that piece to give me 5. Well, we can do it mentally because it's a simple, basic equation. It is useful when we are having our eighth grade versions, variables on both sides. That might not be as easy, or when we include distribution and all these more complicated concepts of algebra, right? And so this is the reason why we solve. So we're going to bring in our algebra tiles, and I'm going to start representing. We're going to start modeling what these numbers and variables look like with pictures, right? And so we're going to click on, so I have how many x's? I have one x. Okay, so our coefficient is 1. Coefficient is 1. So what that means is that I need to multiply the value of x times 1. And so I'm going to bring, doesn't matter which one you bring, I'm going to bring in my horizontal. Oh, what happened to my balance when I did that? Well, because I'm adding weight, I'm adding something to the left side, it's going to become uneven. It's going to be heavier on one side. But I'm not done. I have one of the x, that's good. Now I need to bring in plus 3. So 3 positive constants. There we go. We have 1, 2, and 3. And so I have successfully represented the expression on the left side. And now I need to represent the expression on the right side. I have a 5. It's a constant. There's no variable. There's no x. There's no y. There's no other variable. So this is a just simple 5. So what you can do is just drag, or you can go ahead and just click copy, and it's going to copy, and you copy as many as you need. That's probably the faster route. And then I'm just going to fix it here. Make sure that your values are in the boxes that are drawn. So it is part of it. What happened now? So go ahead and discuss, why do you think it balanced out? What does it mean, right? So what we should have gotten is that, again, the value, the weight in this case, on the left side of our equal side is equal to the weight on the right side. Okay, so what missing piece is going to get me to balance? And this is where we bring our isolations. We isolate our variable, the x, our variable x. How? By doing inverse operation on everything that's bothering the x. So in this case, we're adding 3 to the x. We want to isolate it. The x wants to be by itself. So we need to undo that operation. And how do we undo the operation? By doing the inverse, right? Inverse just means the opposite of whatever we're doing to our variable. And so right now we're adding 3. So the inverse of adding 3 would be to subtract 3. And so to represent this, to model this, I need to click on the constant, and I'm going to click negate. You see how I popped up this menu here? We're going to click negate, and then I want you to notice what happened. It went from positive to a negative, right? In this case, we were adding 3, so now it's going to subtract, and we have to do it one at a time. So I'm going to grab my first negated or inverse constant, and I'm going to drag it over to the other side, because notice what happened to our balance. It's no longer equal again because I removed it. So what I'm going to do is I'm going to hover it over, and then I also want you to notice what happened when it did that. What happened to one of the constants on the right side? It became a 0. That is what we call our zero pair, right? We are pairing one of each sign. So we have a positive, and now we have a negative, or in this case, it was +1, and now we did -1. So 1 minus 1 is 0. So we successfully created a 0 pair, and we have to repeat the process because it's not isolated yet. And so here we go. There's my second 0 pair, and then I still have one more. It's not completely isolated. It's almost there, but not quite. So now the question is my x by itself, is it isolated? The answer is yes. What is the value that it became equal? At what value does your x become equal? Does 1x become equal to? 2, right? So we have x is equal to 2. That is our solution. It's still balanced. So what I'm going to do is I'm going to show it here, x equals 2. Well, I'm not quite done because I still need to check, did I do this right? Well, what does it mean for x to equal to 2? All that means is that I found the missing piece. I will need to substitute every variable of x with this value of 2. So that's what I'm going to do here. So this is no longer here. This x is going to get substituted because I found what I was looking for. I found the missing piece. So now I'm going to put 2 plus 3 is equal to 5. Well, let's simplify. What is 2 plus 3? It is 5. Does 5 equal 5? The answer is true. So we have successfully solved our equation.